Hi, my name is Anna, and this video is a school project about pH. Today we will talk about the different pHs and watch the process of a pH measurement with red cabbage. Yes, red cabbage. This vegetable can be used to measure pH because it contains a pigment called anthocyanin, the purple one, that changes colors when mixed with a base or an acid. That's why you can tell the pH of something when mixing it with cabbage water, because depending on how acid something is, the color will be different. So all you need to do is to extract this pigment from the cabbage. So you can mix cabbage with water, or you can boil it and then you will have the pig. This water will be used as instrument. But first, what is pH? pH is basically the measure of how acid or basic something is. pH is the measure of acidity, and it stands for potential or power of hydrogen. The reason is the more hydrogen you have, lowest is your pH, and the less hydrogen you have, higher is your pH. Talking about formulas, you know. So pH is defined by a pH scale. This pH scale goes from 0 to 14 and name things acids, neutral, or bases, or alkalines, according to its number on the scale. So from 0 to 6, something is acid. In the red cabbage experiment, colors like red, pink, and so on are called acids. Things like shampoo, coffee, lemon, they are acid. 7 tells that something is neutral. So you basically don't have too much hydrogen nor too less hydrogen. It is balanced, so it's neutral. And then from 8 to 14, it's a base or alkaline. In the red cabbage experiment, colors like blue, green, and yellow tells you that something is a base. And it means that you have more hydrogen on that molecule or formula. Things like baking powder, soap, bleach, or toothpaste are bases. So the point on this video is to make a pH scale with red cabbage. I chose 7 different things to show different pHs on the scale. So in the following video that you're looking at it now, we have lemon, disinfectant, shampoo, water, baking powder, soap, and bleach. First, with lemon, when lemon is mixed with the red cabbage water, it turns into red, telling us that lemon is acid. Then we have disinfectant, and I swear this is pink. It's kind of purple on the camera, but it is pink, meaning it's also acid. Next, we have shampoo. It also looks purple on the camera, but in real life it is pink, meaning also acid. Next one is water. The color doesn't change. That's because the pH on the water is neutral, so nothing changes. That's why the red cabbage water, that is purple, when mixed with water, stays purple. Next one is baking powder. The baking powder is mixed with a little bit of water, so the reaction would be easier, so yeah. And then when it is mixed with red cabbage water, it turns into blue. Kind of purple on the camera, blue in real life. And that tells us that baking powder pH is a base. Next, it's soap. Also with a little bit of water. So when this soap is mixed with the red cabbage water, it turns into green. Later on, it will be kind of yellow because the pH is kind of reacting, but it also tells us that it's a base. And the last one is bleach. When bleach is mixed with the red cabbage water, it turns into a really dark yellow, kind of brown, but then it gets lighter, kind of yellow, almost white or transparent, but still yellow. Also tell us that it's a base. So this is our pH scale. Kind of pretty, right? A lot of different colors, kind of like a rainbow. A pH rainbow. Cool. Okay, so to finish that, applications of pH in real life. How is pH around us in our days? So in this video, I brought 3 examples. The first one, human body. The pH is really important for many areas of our human body. The example that I brought here is in our digestive system. Next is development of pharmaceutical drugs. Acidity can affect drug metabolism. So the pH is really important on pharmaceutical drugs. Because if the pH is wrong, once we took them, we can have like some effects that we don't expect. And last one is foods. Yeah, foods. So microorganisms are sensitive to foods pH. So very low or very high pH can prevent microbial growth on fruits, vegetables, everything that grows like in farms and etc. So yeah, pH is important also in our foods. And yeah, that's it for today's video. I hope you enjoyed and understood what is pH. Thank you and